if you assume you have the work group set up and you've identified a workflow, you know, essentially, so this needs to be renamed to a work step in the diagram.
Yes.
We can do that. So if you've got a workflow going, this is what one step in the workflow. This is what one work step.
Before you go there, how do you set up a workflow? Like, you know, what's the next thing that I need to know about from that perspective? So you've set up a work group, but that's just a collection of accounts and endpoints that represent these three ABC company.
Yeah, so that's where the privacy package comes in terms of.
Oh, that's interesting. Why I wasn't expecting privacy to be the next thing to come out of your mouth.
Yeah, I mean, this is sort of how, like, the way that, you know, anytime you know you want to deploy a new workflow, you're basically going to have a shield verifier pair as of the current implementation, and you know what that means is you basically need your first circuit to really get moving on that. And so you might as well just simplify it all the way down into the privacy package. And we basically have some tools here that are shown off in such a way where you can conveniently, without a lot of code, with basically one line of code, compile and run a trusted setup for a new circuit.
Okay, so let's start. Let's just blow back for a second. What you're talking about. So just to set context, what you're talking about is that once you have, when you're setting up, once you've got a work group, you're going to set up a workflow, right? Which is a set of logical steps between these companies. And in order to do that, do that on chain under zero knowledge, you're going to have to run a setup. Is that correct? Based on the current tooling that we have in place, yeah, you're gonna have to run a zero knowledge setup, right? So this is going to allow you to do a one-time zero knowledge circuit setup. Is that correct?
Yes, it is. And so we have this IZK Snark circuit provider, which is the interface for that we see to be very standard for creating ZK Snark circuits, regardless of what front end and back end you're using. Whether that's like Socrates and Bellman or something else, you should be able to use this interface interchangeably with ZK Snark circuits. And because of that, so like, for example, the example app has a method called deploy work group. And what that method does is it takes the application specific circuit that is being used, and it runs it through the compiler, and then it runs the trusted setup. So all you got to do is call deploy workflow, and it returns the trusted setup artifact with one line, and it basically gives you
more elegant than what we have been working with. That's nice.
It's a one-liner to get back to the trusted setup artifact, which is an identifier, a UUID basically, that is used in a protocol message later, and also within the circuit registry, if you will. The key pair itself, and then the Solidity source code for the verifier contract. So once you call
in context, this is all. So it's important for everybody to know that what's happening is, and this is for so the first thing you would do, you're setting up the work group. Second thing is you're going to either use the generalized Socrates or zero knowledge circuit, which is effectively just, hey, everything's the same. It's a consistency check. Or you're going to have some more sophisticated zero knowledge circuits that you're going to want to set up, already set up for this particular workflow, this particular application, right? So step one, get together with the companies you want to get together with. Step two, decide whether you want just consistency machine or something more.
Or like the Radish PO, for example, like the MSA PO from Radish would be an application specific example.
Right. Okay. So yeah, like in the Radish demo, we have a master service agreement circuit that has more business logic in it than just consistency. So you would set all that up first, and then you would run what you just described, right?
Yeah, yeah.
All this is so that we can basically do this confirmation of consistency on chain with under zero knowledge and privacy.
Yeah, and I think this will extend really nicely to other use cases. It's very it's application agnostic, so it'll scale, I think, quite well. Karthik, I've been working with him on theorizing a design on how to make these become chainable, and so we have a very generic one up front, and then we can maybe we're looking into how to chain that with additional circuits. It's not included in this initial release, but it's something that just to be aware of the way we're thinking about it.
Terrific.